Hello everyone. Today let's solve the problem number 72. Edit distance. Right. So what the question states here? We are given two words, word 1 and word 2. You can clearly see here. We are given two words, word 1 and word 2. What is our main task here? Our main task is to determine the minimum number of operations that is required to convert word 1 into word 2. So we need to convert word 1 with word 2 with the minimum number of operations. We have word 1 and word 2. We need to convert word 1 to word 2 with minimum number of operations, and they have given certain operations. The allowed operations are here. You can clearly see: insert a character, delete a character, replace a character. So these three are allowed. The allowed operations are: one is insert a character, second one is delete a character, third one is replace a character. Right? We need to find the optimal way to transform word 1 into word 2 with the minimum number of allowed operations, nothing but insert, delete and replace a character. Right? I hope this is completely clear. Let's come to example 1. So here they have clearly mentioned horse and ROS we have. So we need to convert horse to ROS with minimum operations, nothing but we can go with this one: insert, delete and replace. Right here. So first step, here output is 3. How? Explanation they have clearly given here. Horse, we will replace H by R here. Right? We have done that one. Replace H with R. This will become RORSE. Right? So second step here is, after replacing, we will remove the R. Right? So when we remove this one completely, R, then it will be ORSE or ROSE. Right? So this is fine. The next step here is we will remove E now. So if when we remove E, this will be ROS. Right? ROS, nothing but finally we got ROS. These we need 3 operations to convert horse to ROS. Right? This is the minimum. Minimum operations that is required here is 3 in this case. So same goes with example 2 as well. Word 1 intention they have given. So here execution they have given. So minimum operations here required is 5. Intention, we will remove T first. We will remove T. Then it will be this one. And we will replace I with E. So here you can clearly see we have replaced I with E. Then replace N with X. Here we are replacing N with X. Finally we'll replace N with C. Finally we will insert U. This will be execution. So minimum number of steps required here is 5 to convert from intention to execution. Right? So my 5 operations is required here. For the first example, 3 operations are required. I hope this is completely clear. I hope the question is completely clear, and I hope what we need to do is also completely clear. Right? So initially let's discuss the approach step by step, followed by edge cases one by one, and finally write the code and discuss the complexities of the code that we have written. So the first step, as usual, let's discuss the let's discuss the approach step by step. The first thing that we have to keep in mind here is we are or will be making use of 2D DP approach. So or we'll be going with the this one, 2D dynamic programming or 2D DP here. I have considered the same example, the first example that they have given in the question. Word 1 horse, we have to convert this one horse to ROS. Right? So the minimum operations that is required here is 3. We have already seen this one. Right? So let's see how can we articulate this one in the form of code. Let's see the approach. Let's discuss the approach step by step initially. Right? So let's go with initialization part. So initially what we will do, we will create m plus 1 into n plus 1 matrix. Again I'm telling, we will create m plus 1 into n plus 1 matrix just for the easy computation. Right? M plus 1 and n plus 1, just remember this one. Right? So this is one thing. So m will be word 1 dot length and n equals word 2 dot length. We know this one. Right? So the initial step here is dp of I0 is I here. This one, dp of I0, this is I, and dp of, we are going with 2D dp, we know that one. Dp of 0j is nothing but j here. When I say dp of I0 is I, we are converting a non-empty prefix of word1 to an empty word2, right? That requires I deletions. This one I'm speaking of. And this one dp of 0j equals j, whatever I have written here. We are converting an empty word1 to a non-empty word2 that requires j insertions. This requires I insertions and this requires j insertions right here. So let's initialize the dp table. Initially, this will be 0, 1, 2, 3. This will be 0, 1, 2, 3, 4, 5. Right? So I hope this is clear. This is the initialization part. Let's move on with the second step. So when I say second step, let me come here. Yeah, we have to fill the dp table using the recurrence relation, right? So as we are going with the 2D dp table, if dp of ij means if word of I minus 1 equals word of j minus 1, then no operations is needed. Directly we'll go with this formula. So dp of ij equals dp of I minus 1 into j minus 1, right? Otherwise, what we have to do, we have to take the minimum of 3 possible operations. So minimum of 3 possible operations is insert, delete and replace. Means here, if word is equal, suppose if abc is equals to abc, word of I minus 1 equals word 2 of j minus 1, then no operations is required at all, right? So then no operations is required at all. Otherwise, what we will do, if it is not equal, suppose in this example, whatever we are considering here, word 1, word 2, this is not equal to, horse is not equal to ROS, right? We have to perform either replace, remove or insert. So 3 operations we have to perform. In that case, for the insert, we'll go with dp of I j minus 1 plus 1. For this one, dp of I minus 1 into j plus 1. For the third one, we'll be going with dp of I minus 1 into j minus 1 plus 1. In this case, we are going replace first this one and delete twice, right? So replace one time and delete twice. So let's come to the dp table here, the final dp table. Let's make the computation here. So here, this will be, I'll go with this formula directly. Insert, delete and replace dp of I into j minus 1 plus 1 for insert, delete dp of I minus 1 j plus 1, and for the replace dp of I minus 1 into j minus 1 plus 1, right? So let's go with this table. So this will be in this case 1, 2, 3 itself, right? So you can just compute. I'll just write the solution directly here. You can just compute for each cell using the formula, right? Next will be 2, 1, 2 for this one. So for the this one or this row, we have already considered this in this row, right? So for this one, so this was initialization. So this part, this we saw in the initialization itself. So we don't have to worry about this. We are starting from this row, right? From HOR we have done. Next step here is S. This one will be 3, 3, 2. And the final step will be here 4, 4, 3. Accordingly with the formula that we have discussed. So this one, always we need to remember the, we need to return the last value that is present in the DP table, right? So this here is dp of 5, 3, right? 5 comma 3, we can clearly see here, this one 5 comma 3, dp of 5, 3 is nothing but 3. So the answer in this case will be 3, right? 3 minimum operations that is required to convert the word 1 to word 2 here as 3, right? I hope this is completely clear. So here, let's write here dp of mn, final answer dp of mn here, nothing but dp of 5, 3 here as 3 in this case, right? I hope this is completely clear. So what are the operations that we performed here? We replaced h with r. We saw this one, horse became RORSE, and this one, second step was we deleted or removed r. This we removed, so we replaced this one h with r. Next step is we completely removed this one, became ORSE or ROSE. Then we deleted e in rows. We deleted this one, ROS became ROS, right? So these three operations we performed here. In this case, you can clearly see the final value, I mean the value in the final cell is 3 here. That's what we need to return. So here in this case it is 3, right? So the solution that we got here is 3, and they have given output as 3 in the question as well. So the output matches here. So the approach works absolutely correct in this case, right? So let's discuss the edge cases one by one quickly. First edge case here is word 1 is empty string. Here you can clearly see. So word 2 is we have considered ABC. So only insertion is needed here. In this case 3 insertion are needed. So output will be 3 in this case. So the second edge case here is word 1 we have ABC, word 2 we have empty string, right? So only deletions are needed here. Again output will be 3. Here insertion is needed because we are converting word 1 to, we have to convert word 1 to word 2, not word 2 to word 1. Here deletions are required. Again, why deletions are required? If we remove A, B, C by one step at a time, A removed once, B removed once, and C removed once. 1 plus 1 plus 1 is nothing but 3. Same goes with here. So word 1, here we will insert A 1, B once, and C once. 1 plus 1 plus 1 here is 3, right? So the third step here is word 1 is ABC and word 2 is ABC as well. Output in this case will be 0 because no operations required at all. We have A, B, C already, right? So no operations required at all here. So this is one thing. The fourth edge case, let's consider the fourth edge case. In this case, we have A, B, C, D, E, F, and word we have A, Z, C, E, D. Mix of operations is required. So the output will be 3 in this case, right? So let's go with the final edge case here. This one. Word, we have the duplicate letters in the word 1. Also we have duplicate letters here as well, but here only deletion is required. If we remove this one A, it will be same. So output will be 1 in this case, right? So in this case, in the 4, we need to A, Z, C, D, right? So here, just give me a second. A, C, E, D. So we will remove this one, this one as well. So output has to be 3 in this case. Okay, so we will remove this one, we will remove B, and we will remove F, and we will this one add, or we will insert this one, what do you call, Z. We'll insert Z. So 3, this one is 1, this one is 2, and this one is 3. I got confused here. Sorry. Yeah, output is 3 in this case. So these are the 5 edge cases that we need to consider. First one was for only insertion needed, only deletion needed here, no operations needed. Third one, fourth edge case was for mix of operations, and the fifth edge case was for only deletions. I hope all the edge cases are completely clear. So this is the approach that we'll be going with, and these are the edge cases that we need to consider. So let's start writing the code. Let's start writing the code. Initially, we'll be making use of length of the word 1 and length of the word 2 within the code several times. So let's assign this one to the variable. So we don't have to write word 1 dot length and word 2 dot length every time, right? So I'll just assign this one to word dot length, word 1 here it has to be. Sorry. Yeah, this is fine. And let me give here n equals word 2 dot length. This is fine. So the next step here is let's initialize the DP table or DP array. So here let me give, this is m into n, right? M plus 1 into n plus 1, array of size m plus 1 into n plus 1. We have already discussed this one in the approach. So as this is 2D DP table, we have considered 2D DP, right? So this one will be fill dot map. This is fine. This will be array of n plus 1 or fill of 0. We are filling this one initially with zeros, right? So this is fine. So let's fill the base cases initially. So we have discussed this one. We know deleting all the characters from the word and inserting all the characters from the word. These two base cases, right? First thing, let's delete all the characters from word 1, and second thing, let's insert all the characters from to word 1. We have seen this one in the edge cases as well. These two are the base cases, right? So this will be a simple for loop here. Let I equals 0, I less than or equal to m, I plus plus. This is 5. dp of I 0 here, this is equal to I. This is fine. For let this one will be j equals 0, j less than or equal to n, j plus plus. This is fine. dp of 0 j, this is equal to j. So first one was for this for loop, dp of I0 equals I. This is deleting all the characters from word 1, right? This is inserting all the characters to word 1. So we have seen this one in the edge cases. So this shouldn't be there shouldn't be any ambiguity here, right? So while understanding, I hope this is clear. The next step we have to do here is filling the dp table. So we are going with a 2d dp, 2 for loops here. For let I equals 1, I less than or equal to m, let's increment I here. For let j equals 1, j less than or equal to n, sorry, yeah, this has to be, let's increment the j here. So the next step, if the characters match, then no change is required at all. abc abc, if we have two characters here here, let's consider, just for the example sake, we have abc, and here also word 2 also abc, then there is no change required at all, right? So here, for that case, we will write the code. So let's articulate the same thought process in the form of code right here. If word of I minus 1 here, this is equal to this has to be word 2 of j minus 1. So we have discussed this one in the step 2 approach, right? So if it is, then what we will do, dp of ij, there is no change required here, right? So I can just give here dp of I minus 1 into j minus 1 directly, right? This is one case. Else what we will do, so just give me a second here. Else what we will do, we have to take the minimum of insertion, deletion, and replace operation. That's it we have to do, right? And finally return the minimum edit distance. That's what. So here, else if the character does not match, then the change is required. Then we have to take the minimum of insert, delete, and replace operations. So how can we articulate this one in the form of code? Simple. dp of I j here, this one math.min of, let me write this one in the next line so that it will be clean here. So this one dp of I minus 1 into j plus 1 plus 1, this is delete operation. Just for the understanding purpose, I'll just write here deletion, or let me write here delete operation, so that we understand clearly, right? So the next step, let's go with the insert operation. So here this will be dp of I j minus 1 plus 1, right? So the next step here is this one, replace operation. So this will be dp of I minus 1 j minus 1 plus 1. So this is for replace. So let me comment this out and write insert operation. This is fine. The final step here is replace operation. This is fine. I hope this is completely clear. The final step, what we have to do here, we have to return the minimum edit distance, nothing but return dp of m and n, rows and columns, right? So here return dp of m n. This is it for the code. So let me format the code once and let me hit the run button. I hope this works. Let's see. So we have error here. So instead of equals, I have given minus in the line number. Okay, let's make this one to equals. Let's see. Let's run the code again. Again, we have one more error here. After argument list missing. what we have missed here. So yeah, I have missed the comma here. This is fine. So let me run the code again. Fill dot map is not a function. Okay, fill we have to give here this one, right? So initially so let me hit the run again, run button again. One more error, word is not defined. Word 1 and word 2 we are considering. Oh, I have given word instead of word 1. Line number 10. Let me come here and make this one word 1. So many typos. I hope this works now. Yeah, you can clearly see here the sample test cases are getting passed here. Let me quickly hit the submit button. So you can clearly see here all the test cases are getting passed here. Means the code works absolutely perfect in this case, right? So let's quickly discuss the complexities for the code that we have written, right? So the approach that we went with here is dynamic programming, or we can just call this one edit distance algorithm, right? So I hope this is clear. So what would be the overall time complexity here? Overall time complexity would be big O of m into n. We went with the 2D DP, right? So why it is big O of m into n here? We are filling the DP table of size m into n once. So if you remember, we are filling the DP table of size m into n in the approach. So DP table, we clearly spoke about that. We clearly saw that, right? So space complexity is also big O of m into n here. So I'll just come here. Space complexity would be big O of m into n as well, because we are storing the results in the m into n table. You can clearly see here m plus 1 and n plus 1, right? So the overall space complexity would be here because of m into n, right? So the time complexity and the space complexity for the code that we have written is big of m into n. I hope the solution or the code that we have written is completely clear. For now, this is it. Thanks for watching, guys.